at tutoring, and we are doing number 1 on the 3E packet. So we have a spear being thrown, and some of the assumptions that we make here. So we have an x displacement, 201.24 meters, and it was thrown at a 35-degree angle. What we want to know is VI. Okay? Doesn't seem like a lot of information to go on. Well, if we do our x and our y, we have a delta x, we have a delta y. What's delta y? 0. Yeah.
Another one we drew in like a little mini triangle like inside there. Should we do that
It's helpful for some people.
Okay, because I have it drawn and I wasn't sure.
Yeah. It can be helpful to do that for yourself. So you know that that's your VI, there's your VI X, there's your VI Y. That can be really useful. Okay, so VIX.
Wait, why is VI or delta Y 0?
Delta Y is 0. Reading this problem, it's landing at the same, they're assuming a 0 Y displacement. We're not saying that he's throwing it from a mountain. We're not saying he's jumping onto a roof that's 2 meters shorter. So we're assuming that there's no actual Y displacement. Now, as it's been pointed out by many, unless he's throwing from a pit in the ground, or he's 0 meters tall, logically there is some Y displacement, but we're fudging here, and I don't like that, but that's just kind of the way you have to do this.
So you always assume if it doesn't tell you.
If it doesn't tell you there's Y displacement, oh, bye, Jacob. Yeah, I would give up too. You should not give up though. You should not give up. You can assume pretty safely that there's a 0 Y displacement here. Okay, so VIX is going to be VI times cosine theta. VIY is VI sine theta. Okay. We know we have some delta t. We don't know what. What else do we have here? We have acceleration on the y-axis, negative 9.81 meters per second squared. Okay. So what we need to do is create an expression for VI. Let's start plugging things in. So looking at our 4 golden equations, what ties? We know on the x-axis there's really only one thing we can use, and that's delta x equals. Delta t equals delta x over VIX. Because that's all we have on the x-axis. There's nothing else to put in there. So we're down to a simple 3-part equation. So we'll end up, reconfiguring that somehow, undoubtedly. On the y-axis, we have a delta y, we have a VIY, we have acceleration, and if we can tie t together, we might have something. So let's try doing this. Delta y, here, I'll do this up here. I'm going to shrink all of this. So let's try delta y equals VIY delta t. I'll have to move this, obviously. Plus 1/2 a delta t squared. Okay. Well, that ties in the things that we have here. That ties in a lot of things we have. So we can do a couple bits of magic. Because that's 0, we can do the whole negative 1 VIY delta t equals 1/2 a delta t squared. Okay? Because that's the case, we can factor out a delta t. We can get rid of a delta t. If we divide both sides by delta t, we can make one of those go away as if by magic, which will simplify our algebra. Whoops, not the whole thing, Moser, just the squared. Which will simplify our algebra later. So far, so good? We're down to here. Well, let's move all this over to the next page. So a couple things. VIY is in fact VI times the sine of theta, and that's equal to 1/2 A delta t. Oops. Well, delta t, we remember from back here, was equal to that, and VIX is VI cosine theta. So -1 VI sine theta equals 1/2 A times delta x over VI cosine theta. So we now have something that we can algebraically rearrange to get to a point where we can solve for VI. That's it. Good with that? This is number 36 in the chapter review. So we have a cliff, we have a rock, and we have somebody kicking it. And we have an initial speed, VI, of 18 meters per second. And we know that it's 52 meters down to the water. What we want to know is how long it takes for the stone to fall to the water and what's its VF. Okay. So things to start with on the X, on the Y. This one was one of the tougher ones of the kicked, flicked, and pushed. So we don't have a delta X.
So do I just put 0 or?
No, because it doesn't have a 0, but we don't have it. We don't know what delta X is.
And we're not finding it?
Probably not. I don't remember. So we know what the VIX is. The VIX is 18 meters per second. And the VIY is 0. Acceleration on the Y is -9.81 meters per second squared. We don't know what delta X is. We don't necessarily have a good way to find it. So let's see, we also know that VFX is going to be the same. It's going to be 18 meters per second. Did you, x-axis. So remember in these kicked, flicked, and pushed problems, actually in all of these, there's no acceleration on the x-axis, so whatever your initial velocity on the x is, it's the same as your final velocity on the x.
You said I'm finding VX?
No, what you're finding is time.
Well, don't you find time and VF?
Well, you find overall VF, yes, you do. That's probable. Okay, so here we've got VIY, delta y, and acceleration. Can we do this? Delta y equals VIY delta t plus 1/2 A delta t squared. Yes, we can.
Now, like, I'm writing.
That goes away.
Would that be on the Y side?
This is all on the y-axis, yeah. Sorry. I just couldn't fit it. So at that point, can you solve for time? Yeah. And then once you've got time, you'll have to merge the axes to get a y velocity. So that should get you time, and we did a little bit of algebra there. Now, for the same problem, to find v, let's copy some of this information. Copy, copy, copy. Paste, paste, paste. Ding, 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 ding. Sorry. Okay. And we had an expression for delta t was equal to the square root of 2 delta y over a. Okay. So we have an expression for delta t. That's useful. So now we've got, we can find, and this is both axes, the crossover. So if we can find VF, then we can find, if we can find VFY, we can find VF. So, we need to find VF in some way that doesn't involve delta x, because we don't have delta x. So, VF equals VI plus A delta T. So could we do VFY equals VIY plus A delta T? By golly, we could. And we know that VFY, well, we don't even have to have, yeah, okay, awesome. We don't have to have anything there because VFY, what's VIY? 0. So it's just equal to acceleration times time. So that gives us VFY. Well, now, if we have VFY and we have VFX, can you find VF? It's Pythagoras. So it's A squared plus B squared equals C squared. Okay. Can you do this part? Because you have acceleration and you have an expression that you can plug in for time. Okay.
I forgot we had a VFX.
Okay. And VFX is going to be the same as VIX because there's no acceleration on the x. Right. So you have this, you're going to solve for this, and that allows you to get that. And from that, you could figure out delta x, you could figure out the angle it lands at, you could figure out the angle, you could do all kinds of fun, stupid stuff. When you're rearranging this, you're taking this all off the y-axis. So this is VIY.
So it's all right.
Yeah.
And then
You want to make sure that you create your expressions treating one axis at a time, and then you can marry them.
okay.
But you want to begin by handling those axes separately.
Okay. And then when we're like doing like VIX, or whatever, how do we know like why does the VI times the cosine?
Okay, and this goes back to sort of breaking down vectors. If I launch something with some initial velocity, and it's at an angle of, we'll say 10 degrees above the horizon,
That makes sense.
there is a component of that initial velocity on the x and a component on the y. So that VIX, we can look at this and say, well, the cosine of 10 degrees on this triangle is equal to opposite or adjacent, which is your VIX, over your hypotenuse, which is your VI. So then the cosine of 10 times VI, well, that gives you your VIX. And we kind of shortcut that once we get used to doing it.
I think I just need
And you knew that, but you needed the refresher. So, okay. Other question. It should always say find maximum height, yeah.
Okay.
If you're looking for delta y max. Okay, so VIX is equal to the cosine of theta VI. VIY is equal to sine theta VI.
does it matter how you read it, or is there a reason why you wrote it the way you did?
No, it doesn't matter.
I just want to make sure for
Doesn't matter. No. Acceleration on the y, of course, is our negative 9.81 meters per second squared. And delta t will probably connect the two. So let's think about in a perfect, what we want is maximum height of the jump. So at VFY at the max, we know that drops to 0. So do we have something that connects the IY, the FY, A on the Y, and delta X? Well,
Oh, because it's like
Yeah.
from here to here.
right, this is, as if he was an object thrown directly upwards, there's a moment here where velocity is 0. So, to get something that connects VF, VI, A, and delta Y, we could go to our golden 4, and we could do VF squared equals, hold on, VI squared plus 2A delta Y. VFY, VFY. Okay.
I'm confused on the VFY.
Well, because remember that at every moment in this path, his y velocity is changing.
Okay.
Okay? It's always accelerating at negative 9.81 meters per second squared, but as he goes up, the y velocity is diminishing. At this little point at top of flight, y velocity will be 0 for a moment, and then y velocity will increase. The x velocity never changes. Remember? X velocity is constant. There's no acceleration on the x for any of these kinds of problems. Unless you have a rocket pack strapped to your butt, your x velocity is not changing. And we do not do problems with rocket packs strapped to the butt because we can't here. We just don't. What you do with your rocket packs at home is your own business. Okay, so if we had a perfect world, we had anything we darn well pleased, this ties our final velocity on the y, our initial velocity on the y, our acceleration, and our change in y position. So we could solve this easily for that point if we just took, so we want to solve for that, so VFY squared minus VIY squared over 2a equals delta y. Okay, happy day, because, hey, looky there. Look, Ma, no hands. We solved it. There's only one problem. So, well, first of all, that's 0. So what we have is negative VIY squared over 2a equals delta y. Do you sense a complication coming? Of course you do. It's physics. Let's move that over there. So negative 1 VI squared sine squared theta over 2a is what equals delta y. Well, that's awesome. That's great, except we don't have VI. So what we've done is we've written an equation that if we had VI, this would be very, very easy to solve. So now we need to find an expression for VI, and this is what gets a little bit trickier. Because VIY squared is VI sine theta, and we're squaring that whole expression. So algebraically we split those.
Question two.
Yes.
If we're doing the type that we did right before this, we never ever include VF.
Because we don't care about VF. Here, we don't know what VF is going to be there. But here we have a point in flight where we know for certain what the final velocity on the y-axis is. And that point when y velocity goes to 0 pegs you to the top of flight.
Okay.
That's how you get max. Right. That's why we have to include it.
That's what confused me before, because I felt like we were just, I know they weren't random, but to me it was like random.
But until
like
you understand the pattern, it feels that way.
Yeah.
Yes, very much so.
didn't understand
Well,
why
and the
it
same
was
thing, and I
so
beat myself over the head with it every year, the same discussion you and I had this morning of like, why can't we use that equation? Oh, yeah, because, and until you know that pattern, it feels like you're just plucking stuff out of, random orifices. It feels like it doesn't come out of anywhere. Okay, so now we need to create an expression for VI, and we have to create an expression for VI that encompasses what? The whole trajectory, because VI is the bigger picture. So, what we're going to do, let me pause this and move some stuff around. Okay, so now we just have to come up with an expression for VI. That's our next challenge. And we need to come up with an expression for VI that looks at the whole total flight path. So, what do we have? We have delta x. It is delta y and delta x. Now, in this case, the nice thing is that delta y overall was 0. So we can look at something like this. We can look at delta y equals VIY delta t plus 1/2 a delta t squared. Okay. And we know that this is 0. Is this the right path? Okay. I knew it was one of the two, and it was either the wrong road, and I was going to get to the end and go, crud, that's not it, or it was the right road. Okay. Yeah, because the other way I was looking at it took only half the path into account. Okay, so then we can do negative 1 VIY delta t, whoops, equals 1/2 a delta t squared. We can get rid of one of those. So now we have negative 1 VI sine theta equals 1/2 a delta t. So now, for delta t, we can bring in our stuff on the x-axis, because we know that, sneakily enough, delta t equals delta x over vix. Yes. Gesundheit. Delta x over vix, which means delta t equals delta x over vi cosine of theta. So now we can put this in for that delta t, and from there it's just algebra. And it's actually, I think, the same algebra you just did recently, right? You're creating an expression for vi, and then once you get the expression for vi, it goes in there.
That delta x up there in the red, that is, or delta y, I mean, that's delta y max, right? Like, that's what we want?
This is, yeah, this
Okay.
is, yeah, and I should have put a subscript there.
I
This
was
is
just
delta y max.
checking.
No, you're absolutely right.
So
That was
there's three
sloppy.
things we're combining. Like, you're gonna find
You
two
combine
equations.
two equations to get, yeah.
Alright.
Wait, what was the question?
This is number 7 on the 3E packet, the scared kangaroo.
Whenever it's sine squared theta, you type in.
Oh, so it was. So I will be shot if I start on number 7.
You
Okay,
don't do it.
so we're given time, we're given initial velocity, we want the x and y displacement, the y max. So we know that this is another one we're going to have to use VFY at max,
Can you at least just
and that's 0.
give me a
We
second?
want to know how high the fence is, we want to know how far away he lands. I have not done this problem, disclaimer, in an entire year. I'm doing this cold.
So how far away he lands is
Is delta x.
Okay.
Right, that's your x displacement, and how high the fence is your delta y, and we're looking at delta y max. So let's address that first, because we've just come off a series of problems doing delta y max.
It never matters then, right? You just do, it's like two separate parts.
It's,
basically.
yeah, it's two separate parts. So for delta y max, if we had our druthers, if we had any variable in the world handed to us on a golden platter, we could do this, because, of course, this VFY 0 is at that point of maximum height in the jump. So we could do VFY squared equals VIY squared plus 2a delta y. And that would be beautiful. And then to find delta y, we just do the whole thing that we've been doing. VFY squared minus VIY squared over 2a equals delta y. And that goes away. So then we're left with negative 1 VIY squared over 2a equals delta y max. Okay, if we had anything in the world that we wanted. Oh, wait, we do. We were given VI. We don't even have to go to the next step of create an expression. Holy moly. Make sure that works. That's beautiful.
No. Oh, you wrote it.
Yeah, we have a VI. So if it's actually that easy, that's crazy. Let's try that. VIX delta t equals delta x. Couldn't be much easier. So on the x-axis,
So wait a minute. I got the right answer, but where are we now?
okay, so to find the delta x, on the x-axis, you have the VIX and you have the delta t. There's a three-part equation that ties those three things together. VIX equals delta x over delta t. Rearrange to solve for delta x. You guys could have done that last chapter. That's awesome. Okay, well that one's easy. Okay, I should be recording this. So this is number 37 for the chapter review. Whoops. Number 37, chapter review, the two boats. So we've got
And then when
This is
you're
boat
plugging
1, so we
in,
have 15 meters
you
per
have to plug
second.
in the VI
Okay.
cosine.
So,
To VI, which we got.
No, the VI is what we were given. It's 8.4.
yes. So let's see, wait.
Yeah.
VIX equals delta x over delta t. No, so delta x equals VIX times delta t.
Like, this is super simple. Why have I not given
Okay? So there's your delta x. Well, now you have to create an expression for delta y using the information you've got on the y-axis.
Oh, yeah, because I keep time.
Right. Okay, so on the y-axis, we have delta y, we have VIY, which is 0, and we have acceleration. So this looks like a fantastic place to use this and solve for delta t. So then if we do the 2 delta y over a square root, we have an expression for delta t, which, lo and behold, can be plugged right into there. Okay? You're just going to do that for both boats, and you're going to look at how far apart they land.
So do I subtract them?
Yeah. If one lands 10 meters out from the waterfall and one lands 7 meters out from the waterfall, how far apart are they? Yeah, that's all you're doing. It's worded in a way that makes it sound really confusing.
Do you have the answer so I can do these two at home?
Yep. Okay, so that's what we have for tutoring, and FIP tomorrow.